Hi everyone, and welcome to part 2 of the rundown on the 2015 probability methods exam. Let's get started. At reception, patients are assessed on the urgency of their condition. This is done within 2 minutes of arrival. It is thought that the waiting time before an assessment is done is approximately normally distributed, so we're dealing with a normal distribution curve again, with a mean of 60 seconds and standard deviation of 20 seconds. What proportion of patients would be assessed at reception within 90 seconds of arrival? Okay, step 1, do a sketch. Our mean is 60 seconds. We don't need standard deviation on this, but 90 seconds, and it's everyone before that. So if that's what we've got, now we know what we need to put in our calculator. So again, menu, button, stat, distribution, which is F5, norm, which is F1, NCD, which is F2. Double check that data says variable on your screen. Lower. Now, we don't know what the lowest value is other than 0, of course. So you could try that. But rule of thumb is that if you just put in some ridiculously low number, because of the way that the graph works, it's going on for ages on either side. So if we just put negative 1,000, something ridiculously low, as our lower, it'll catch everything that we need to. Upper, as we can see, is 90. So we'll put in 90 for upper. Standard deviation is 20. So we'll put that in when we see omega. Mu is the mean. That's 60. We'll hit execute, and we get P is equal to 0.933. Round it to what you would like. Just don't go on forever. I'm just going to 3 decimal places. So 0.933. Have at least 2 decimal places. Don't just round it to 0.9. Okay. So here we've got a survey is carried out on 80 patients who arrive at reception. Patients are selected at random on a particular day. The results are shown in the frequency histogram below. Okay. Hasn't asked us anything yet. What proportion of patients in the survey were assessed at reception within 90 seconds? So we want 90 seconds. And we know that it's out of 80 patients, which is up here. So our proportion is going to be out of 80. Right, so we want all of these ones here. So let's see, we've got 5, 11, 7, is that 17 or 18? 17 and 19. Here we've got 14. I'll show you why I'm doing this soon. Okay, here's our cutoff line. We only want everything along here. We've got 2 ways of doing this. You could add all of those together and put it out of 80. So that is 60. And then that will give you, let's see, 60 out of 80 is the same as 6 out of 8, which again is the same as 3 out of 4. So 3/4 gives us 0.75 or 75%. And the other way we could do it is we could say proportion is equal to 80 minus add these two together, which is 20, out of 80, which still gives us 60 out of 80, which is 0.75. Okay, so depends on how you think, because it's always going to be out of 80. We know that all the ones down here are obviously going to be all of them minus these ones at here. That's why we've done it the second way. If that doesn't make sense to you, the first way is perfectly acceptable. Okay? Okay. Last question for this video clip. A statistician states that the assessment times are not normally distributed, but are more likely to approximate the distribution P of X below. Approximate, I should say, sorry. The associated probabilities with minutes converted to seconds are given in the following table. Compare the frequency histogram for the survey of 80 patients with a distribution curve. You should comment on the comparative shape, center, and spread of the two distributions. Okay, so we want some kind of comparison. And here they tell you shape, center, and spread. Okay. You could add a comment on proportions as well, considering that the last question back here did ask about proportions. Okay. So we want at least something on the shape, center, and spread of the two. So here, let's look at this. Whoops. If we got a different color, could we do it like that? Or should we be drawing it like this? I think the first way is better. Okay. Because if you look at this, there's two peaks, and it's quite clear, isn't it? Then this one here, we've got one peak. So for our shape, let's use... So we've got shape. Survey. Versus the P of X. If we look at this, so this is one way that you could set it up, is say shape, survey versus P of X. You've got, and then jot your points down here like this, so you can, so whoever's marking can see how you're comparing it. Then you'd have center, sorry, bad writing on this, and spread. And continue on with your points. Okay. And remember, you're given space on the other page, so it's perfectly okay to use 2 pages. Okay, so let's talk about shape for now, shall we? So this one here, whoops. So this one here clearly has 2 peaks. Whereas this one over here has 1 peak. What else can we say? Does that look like a standard normal distribution? Not really, eh? They're both skewed to the left. They've both got tails to the left. Can we see this? So you could say that they're both left skewed. let's see. If we look at the center is around about here, 75 to 90 seconds. Whereas the center here, what's the center here? We're looking at about let's see if that's 1.5, 1.1, 2, 3, about 1.35 as our center. Okay. Or 1.34 if you like. No, about 1.35 is more the center. That says minutes too. This, what else have we got? Spread. So here we've got 0 to 2 minutes. Here we've got 0 to 120, or 15. Yes, 15 to 120. Okay, so the spread, let's see, what's 120 minus 15? Gives us about 105. So the spread is quite far in that. Oh, but in saying that, let's put this into perspective. So 120 seconds is equal to 2 minutes. Okay? Yep, it's 2 minutes. If we convert 2 minutes, that's 120 seconds. 1.35 minutes that's about a third. So that's about 20. So that's about 80 seconds as the center. I know, sorry, I went back to the center. And the spread here is about 2 minutes as well. Well, it says up to 2 minutes. Let's double check this. 2 minutes, yep. But the range is cut off here. So the range is smaller on the first graph than it is on this one here, on the second one. Alright. Proportions, how many people? The first one was out of 80. Okay, so we can't really say what the people would be, but we could look at where the proportions of these numbers sit compared to the second graph. So here, most of them are in the 75 to 90 bracket. So that's a minute and 15 seconds. Which is less than a third. So again, so the proportions are about the same where everything is. It's just that on the second graph we've got a larger range, so everyone's a bit more spread out. And that's about it. Okay, thanks for watching.